Let's start part 3, which is nomenclature of your summer homework. So you have your periodic table all right here. I recommend you download one that could be helpful as well. Now we remember that all of these in this column are +1, all of these are +2. Skip the transition metals. These don't have a charge or oxidation state. These are -1, these are -2, these are -3. And so we remember that. And we remember that transition metals are things that can have more than one oxidation state. Kind of like iron can be a +2 or a +3, right? Technically, it could be more. Now, zinc is always going to be a +2, always, always. Technically, zinc is not a transition metal. And silver is always just going to be a +1 or just a plus sign. Okay, so now if it's here, a cation is something that, remember, a cat has pause, so a cation is positive and anions are negative. Now the difference between type 1 and type 2, type 1 is something that is not a transition metal, like something from group 1 or group 2. And then type 2 is a transition metal, and they must use a Roman numeral, kind of like these right here. Okay, so you have your polyatomic ions. I already made a Quizlet for this so that you can study this, but we'll do this at the very beginning of school, all right? So, and the nomenclature, you can review videos or kind of remember how we go, but let's just start with the examples. Write the formulas for each of the following compounds. Potassium bromine, well, that's potassium and bromine. Well, K is in the first group, so it's going to be K plus, and then bromine is in the 17th group, so it's going to be a minus. The plus and the minus cancel out, so it's just going to be KBr. Now, lead nitrate, that's lead, Pb, and then nitrate, we know is NO3. Okay, so those polyatomic ions just come right in there. Now, nitrate is NO3 with a minus charge. You just have to know that and memorize it. So now the charge of lead is going to be 2 because the Roman numeral is 2. So it's lead 2 plus. Now remember what we have to do is we have to crisscross those, right? So the 2 has to come over on the outside, and then this -1 charge is to come over on this side. So if we crisscross that, we end up with lead, and we have 2 nitrates. And we have 1 lead and 2 nitrates, right? So sodium sulfite. So that is going to be a 2 minus charge, so that's going to be Na2SO3. And then ammonium phosphate, that's going to be NH4. And then that has a plus sign, and then phosphate, 3 minus. So now what we'll have to do is we actually have 2 polyatomic ions right here. So make sure that you put that polyatomic ion, group it together still, and do that. And yeah, don't do any funky stuff like multiplying all those by 3 or something. Just put parentheses around it, put a 3. And that's what we should get. Now we want to name the following compounds. This is going to be sodium fluoride. Now this is iron sulfate. Iron's a transition metal, so I'll leave room for Roman numeral. Now we have to determine what Roman numeral. Well, sulfate is a 2 minus charge, right? Well, and since there's only one sulfate, to cancel out this one iron, this iron has to be a 2 charge as well. Okay? So that's a Roman numeral 2. Now this iron, that's iron sulfate again. But this sulfate was a 2 minus charge. There were 3 of them, so that make that like a 6 minus charge. It's total, right? And then this iron was some charge. This one has to be a positive 6. So that must mean that it was a positive 3 because there were 2 of them right here. So that is iron 3 sulfate. Iron can be a 2 or a 3. And then this is going to be zinc oxide. Remember, zinc is always going to be a +2, right? So if it's always +2, it doesn't need a Roman numeral. And it's also technically not a transition metal, like I said earlier. Okay, so that's the ionic bonds. Let's do covalent bonds. Covalent bonds are easy. You may want to skip forward, but remember all the prefixes, 1 through 10. If one is mono, di, tri, tetra, penta, hexa, or hex, hepta, oct, non, dec. Easy, right? So if we have something right here, we're just going to take the name, the chemical, and just add a prefix to it. So it's going to be di, nitrogen, monoxide. Make sure you don't put 2 O's right there. Don't put monooxide or monoxide. It's just monoxide. Xenon. Ooh, xenon's a noble gas, but ooh, guess what? It can bond difluoride, phosphorus, phosphorus, pentafluoride. Oops, sorry about that space. And then phosphorus trichloride. So that's easy, pretty simple. You should be able to figure that out. Now remember that a covalent bond is something that's between a non-metal and a non-metal, right? A ionic bond is between a metal and a non-metal, but a covalent bond is a non-metal non-metal. Okay, so that's how you see the difference, especially when you start doing your examples. Hey, so acid nomenclature, only 3 rules to understand. If the polyatomic ends in "ide," or if the anion ends in "ide," it's going to be hydro something ic acid. If it ends in "ite," it's going to be something us acid. And if it ends in "ate," it's going to be something ic acid. So this is sulfate right here. I'm sorry, this is sulfite. So sulfite is going to be sulfurous acid. HF is going to be hydrofluoric acid. PO4, that's phosphate, so it's going to be phosphoric acid. And then this is acetate, so we're going to call it acetic acid or ethanoic acid. And now the formula for this: nitric acid, HNO3. Chlorous acid is going to be HClO2. Carbonic acid, H2CO3. And then hydroiodic acid is HI. That concludes the example part. Your assignment is all of these, and I understand that you can probably just look these up on Google very easily, but really try not to. Check your answers on Google. I don't have a problem with that, but please do your best on these because these are super important. These are not to be made mistakes of later on in the year. All right, have a great day.